So earlier this morning, I posted the PowerPoint and the PDF for yesterday's lecture. I'm just going to finish off that deck of lecture slides today, and then I'm going to switch over to the notebooks, and we'll look at we'll do some of the examples in the notebooks. All right. So at the end of the last class, we were talking about basically how to use the shell, and I was talking about command line completion. I'm going to skip over this page for now and just jump into the wildcard section. So everything that if you're working on the command line on your Unix or Linux system, right, then inevitably what you're doing is you're working with files, right? You're looking at directories, you're looking at what files in the directories. You might be manipulating the files somehow, right? It's not super different than how you use a computer with a graphical user interface, right? Normally, most people on their computers are accessing files of some kind. You edit them differently than you would from the command line, so you typically open up some program to edit them, but the idea is the same. Because the files and file names are so important when you're working on the command line, there are what are called wildcard characters that let you specify file names using a very primitive form of pattern matching. Right? And so you have to remember that the stuff I'm talking about now only applies to, what's the best way to describe it? Only applies to something called file name expansion, which I'll explain in a notebook shortly. Right? Later on in the course, you're going to see that there's other ways to match patterns. All the other patterns are specified. The rules for specifying those patterns are different. Right? So this applies to when you want to match a file name. Okay, so these special characters called wildcards. The wildcards let you specify, so easily specify groups of files, right? So files where the name matches some kind of pattern, right? They're also called globbing patterns or globs, or what else do they call them? Well, globs are wildcards. You can find out about them. If you want to see the man page on them, you can type in that command there to find the man page. But I'm just going to explain them to you in the slides. All right, so when you specify a file name, you are allowed to use the star character as part of that file name. Right? So if you specify the star, or if you use the star to try to match a file name, right, what the star matches is it matches any number of any characters. Right? So basically that matches everything. So let me show you an example of that. All right, so I'm in this directory. If you have the notes installed, you'll have a directory called CISC220, then there's notes, then there's bash, then there's scripts, and I'm in the file name expansion directory, if you want to follow along. Right? So in this directory, there's just a bunch of files, right? Mostly they're empty, so they don't mean anything. Right? So if I type in ls, you get the listing of all the files. Right? If I type in ls star, right? So wait, let me go back up one. So if I type in one file name, right, ls prints out information about that file. Right? Remember, if you want to get other information about that file, like its size, you can type in -s like that. Right? It says it's 0, so it's basically empty, and it is. Right? Now, what happens if you type in more than one file name? Right? So ls will accept, well, a lot of Linux commands will accept more than one argument. Right? So for example, ls will list the contents of more than one file, or list information about more than one file. Right? So I can say ABC and ABC like that. Right? And you will get information about both of those files. Right? You want it in single column format, put in a 1. Right? If you want the detailed information, put in an L. Like that. Right? So ls will accept multiple file names, right? And most commands that operate on files will accept more than one file name. So man ls, right? That's what this means here when you look at the man page, right? So ls says it takes in 0 or more options followed by 0 or more file names, right? So that's what the square brackets, remember, means that it's optional, right? ... means 0 or more. Well, sorry, the square brackets means it's optional, so 0. The ... means as many as you like. Okay. So what happens if I want to, say, find out information about all the files that begin with or that end with PDF, right? So I can do ls, oh, let's just do ls star. Star matches any number of characters, right? So when I type in ls star, what happens is this star, it gets what we call expanded, right? So this becomes what's called a file name expansion. That star expands to match every file name that's in the directory, right? Every non-hidden file name in the directory. Right? So it matches 0 or more characters, right? So star matches 00.pdf, right? Because that's a sequence of 5 characters. It also matches 10.pdf, a sequence of 5 characters, right? It matches the single A. So if I type in ls star, let's do ls minus l star, right? You get information about all the files, right? It doesn't match the hidden files, so you don't get information about dot or dot dot, right? If you ever want information about the hidden files, you need A, right? So if you want to, sorry, what just happened there? Oh, sorry, star doesn't match, unless you configure your shell otherwise, star doesn't match the will not match hidden files. You can change the behavior of your shell so that it will, but mine's not set that way. Okay, so you can now combine this with other characters in your pattern, right? So notice I've got 3 files here that begin with a capital F, right? So if I want information about all the files that start with capital F, I can do ls f star, right? So that says match all the file names that start with F, right? Followed by any sequence of characters. So now you get file 1, file 2, file 3, right? I've got a bunch of files that end with Z, right? So if I want all the files that end with the letter Z, it's ls star Z, like that, right? And now you get all the file names or information about the files that end with the letter Z. Right, so star is one of the wildcard characters that you can use when you're trying to match file names. Right. Now, what happens if you just want to match any single character? Right? So the question mark matches any single character. Right? So question mark will match any of the letters A through Z, all of the numbers. I don't believe it matches dot by default. Right? So again, you can't. It won't match to the hidden files either. Right, okay, so suppose you want all the file names that are 3 characters long and start with the, sorry, all the file names that are 3 characters long start with X and with Z, right? So that's lsx question mark Z, right? Question mark matches any single character, right? The file name must start with an X, must end with a Z. So that's any 3-letter named file. Starts with X, ends with Z. Right, like that. If you use square brackets and then put a bunch of characters inside the square brackets, right, then that will match any of the characters that are inside the square brackets. I think there's an example. Yeah, here we go. So let's look at this slide here. Right? So there's a whole table of examples here. Right? So if you're going to use the square brackets, right, this will match 1, right? Any one of the characters inside the square brackets. Right? So this says match any file name whose name starts with X. Right? It ends with Z, and the middle character must be a lowercase y, an uppercase y, a 1, or a 2. Right? All right, so in the next example here, starts with an X, ends with a Z. Right? And now you've got what's called a range. Right? So A hyphen Z means any of the lowercase letters A through Z. Right? So you have to be careful about using the hyphen inside of these square brackets. Right? If you use the hyphen inside the square brackets, then the shell will try to interpret that as you're trying to indicate a range of some kind. Right? So let's look at that example there. So A through Z. So X, A through Z, followed by a Z, followed by a lowercase z. Right? And so here you've got XAZ, XYZ, but you don't get X1Z, X2Z, or X at Z, right? Or the X capital YZ. right? It only matches one of these characters in here, right? If you really want the hyphen, if you really want to try to match the hyphen, which would be not that unusual in a file name, right? The hyphen has to come first or last in the inside the square brackets. You can use a range of numbers if you like, right? So 0 through 9 is the range 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Capital A through capital Z is the range of all uppercase letters. Right? If you try to do something unusual, like big A through little z, I'm not exactly sure what happens. So I don't know exactly how it's defining what that range might be. The other thing is in bash, you may not get an error. So let's give it a try and see what happens. So something like that. So I have no idea what this is going to do. OK, so here it says it can't access x square bracket a minus big Z through Z, right? No such file or directory. So it looks like what's happening is that range is either not valid, and bash is interpreting that literally, or the shell is interpreting that literally as being the characters square bracket a hyphen big case uppercase Z closing square bracket. Right? So don't try to get fancy with your ranges. Just use the simple ones. And again, you can mash all this stuff together. Right? So the last example here says, match any file name whose first character is a 0 through 9, right? Whose second character is 0 through 9, ends in .pdf. Right? So that's all of my files. 00.pdf, 10, 20, 30, 40, and so on. Right? So ls 0 through 9, 0 through 9 .pdf, like that. Yeah, question?
Have like a range in a set of brackets with another character. Like, let's say if I wanted it to match with a digit.
Yes, you can combine all the stuff together. So suppose I want, wait. Let me just quickly make something up here. 0 through 9. So you want to go, OK, so I'm going to copy. I'm going to explain how to copy and move files and things like that later on. So 0a.pdf. OK, so now I've got a bunch of files that have 2 digits, .pdf. I also have a 0a.pdf. Right? So if you want to get that, all of those files plus the a, 0, right, you can do that. Right? So now it's the range 0 through 9 and the character a. Right? And now you get the 0.pdf. Right? So the square brackets indicates a set of characters. Right? There's not supposed to be any repeats, but I'm pretty sure bash lets you repeat characters if you want. Yep.
So is it possible to match the hidden files?
Yeah. So you have to explicitly specify the dot. So touch a.b.c. OK. So I just made the hidden files .a, .b, and .c, right? You also got the hidden directories dot and dot dot, right? So the current directory and the parent directory. If you want to match those files by default, so the way most of your shells are probably set up, then you have to explicitly say, I want the file that starts with dot, right? So dot star says, give me all files that start with a dot, and then anything else. Right? So there's .a, .b, .c. I guess there was a hidden file, a .hidden1 and a .hidden2. Right? And this was a good example, so I'm glad you asked this question, because bash does the shell does something different. ls does something different if you ask for a directory as opposed to a file. Right? So what does .star match? It matches any file that starts with a dot. Right? So .a, .b, .c, these as well. Right? It also matches the directory name dot, right? The current directory. And it matches the parent directory, right? The directory name dot dot. Right? Because that dot says any file that starts with a dot followed by any character. Right? So if you ask ls for information about a file, right, you get information about the file. But when you ask ls for information about a directory, you get the contents of the directory. Right? So the behavior of ls is different if you are asking for information about a file versus a directory. Right? Now, a lot of the time when you do this, or there will be many instances when you do this sort of thing and you don't care about listing the information in the directory, right? The files in the directory. What you really want is I want the directory name, right? So I want to know that there's a dot and a dot dot directory. And let me make another directory. So make dir dot hidden dir, right? And we'll do the same thing again. So ls dot star, right? And now you get you see that there's this directory called dot hidden dir, right? So a lot of the time, if you're processing, you'll see shortly in a few lectures, when you start to process all of the files in a directory, right? Typically, you don't want. Typically, you only want the file names. You don't care about the file names that are in other directories, right, or that are in directories. So you can suppress the output. Ls dot, yes, so you can suppress, what ls does when it prints or when you give it a directory as a name, right? So the D option to ls says, if one of these things is a directory name, just print out the directory name. Don't print out the contents of the directory, right? So now it prints out, yes, you've got a directory called dot dot, you've got one called dot dot, and you've got one called dot hidden dir, right? If you take off the -D, it gives you the files that are in those directories that matched, right? So here are the files in dot, right? Here are the files in dot dot, and here are the files in dot hidden dir. Right? And so -D is a useful is an occasionally useful option to remember for ls. Right? Okay, there's also something called standard character classes. So these are called the POSIX character classes. Right? Now you have to be careful when you use these, right? Because I showed you this square bracket thing already. When you use the POSIX character classes, right, these have to go inside of square brackets as well. So this is what you put inside of the square brackets here, right? So it's this example right there. Right? So there's lots of times when you want to match the digits or just numbers, or sorry, digits, numbers, same thing. When you want to match just digits, when you want to match just alphabetic characters, right? You might want all the letters and all the numbers. You might want symbols, and so on and so on and so forth, right? Lowercase letters, uppercase letters, right? There's a bunch of these predefined character classes that you can use, right? So for example, square bracket, colon, AL_num, colon, square bracket, are all the alphanumeric characters, right? All of the characters that are letters or numbers, right? Alpha is all the alphabetic characters. You can get all the spaces, you can get all the symbols or the non-alphabetic characters, and so on and so on and so forth. The notebook actually lists the, but where are they? Is it quoting? Where to go? Not quoting. File name expansion. So in the file name expansion notebook, it actually lists all of the POSIX character classes here, right? And again, you can just Google this as well, right? So you can see, you can get all the space characters, all the lowercase characters, all the characters that you can actually print, punctuation, so these are all the symbols, and so on and so on and so forth. Right? And again, you can combine these with the previous wildcards. Right? So square bracket, colon, upper, colon, square bracket, star. Right? Match all the files starting with the capital letters A through Z, or starting with a capital letter. Right? So ls, sorry, upper. Star. Right? Gives you all the file names that happen to start with an uppercase letter. Inside the square brackets, the first set of square brackets, you can negate the set of matches. Right? So the exclamation mark inside the square brackets indicates that you want to match all the characters that are not uppercase letters, right? Followed by any sequence of characters. Right? So exclamation mark followed by the POSIX character class negates that character class. Right? So these are all the files that do not start with a capital letter A through Z. Right? So up arrow. Oh, I didn't show you this. In your shell, the up and down arrows will cycle you through the history automatically. Right? So if I press the up arrow, it goes back to the previous command. If I press it twice, it goes back to the command before that. Like a third time, it goes to the command before that. If I press the down arrow, it then goes forward through your history. Right? So now it comes back to the second last command. That's the most recent command. Right? One more time takes you to the current command. Right? So I can just go up arrow once, edit my command, right? And now you get all the file names that do not start with an uppercase letter. Right? And finally, the last example here is, so it's X followed by 1 digit. Right? So that matches any 2-character file name that starts with an X, ends with a digit. I don't actually know if I have any of those. I do not. So this will match nothing. So X, X, colon, digit like that. Right? So if ls doesn't find any files that match your pattern, it tells you there are no files that match that pattern. All right, so that's how you use the wildcard characters to match groups of files. Right? I think the notebook has a few more examples of when this is actually, does that? Oh, no, it doesn't. Oh, here we go. Here's one. Let me quickly go back up. Okay, let's start. Can't start. Okay. I have to run this one here. All right, so cat is another one of these programs or another one of these commands that you can use. Remember what cat does. Cat, did I show you? I haven't shown you cat. I don't think. Is there anything here that's not empty? Just a second here. Nothing here that's not. Okay, so I just got to find out what directory this wants me to be in. Scripts, file name expansion. Yeah, is there actually anything? Oh yeah, a.text has something in it. All right. So if you have a text file and you want to know what's in that text file, right? If you want to quickly print out the contents of the file, right? That's what cat will help you here. Oops, sorry, wrong directory. Okay, so cat a.text. So the file a.text just contains a few lines containing some letters that words starting with the uppercase letter A. Right? So the cat program will print the contents of the file to the terminal. Right? Now, obviously, if you have a very, very big file, cat's going to print out a whole bunch of information. Right? So cat's not necessarily the best way to do this. Right? If you want to know what does this file start with, there's a command for that. Right? So if you are trying to find some file, you're not exactly sure which one it is that you want to be looking at. Right? So you've got a bunch of choices here, and you want to know quickly what does each one of these files start with. That's what the head command is useful for. Head prints out the first 10 lines of a file. Or you can ask it for the first n lines of a file. Right? So the head command outputs the first part of a file, right? Minus n, followed by the number of lines will print out that many number of lines of the file. Right? So head minus n5, a.text, will print out the first 5 lines of the file a.text. Right? Cat prints out the entire thing. Right? Is there another text file in here? So let's look at what's in little a.text. Okay, so little a.text is a bunch of words that start with the lowercase letter a. Right? If I want to mash all of these things together, right, I can do cat a.text and a.text like that. Right? So cat is actually short for concatenate. Right? So it concatenates the contents of 2 files, prints the result to the screen. Of 0 or more files, printing the result to the screen. Right? So cat a.text followed by little a.text, print the contents of big a.text, followed by the contents of little a.text. right? And so here you can see you get all the words that start with uppercase A followed by the contents of little a dot text, right? Now imagine you had a whole bunch of these files, so B, C, D, and so on and so on and so forth, and you want to mash everything together, right? Then you can do something like cat star text, right? Or star dot if you like. It doesn't matter which one in this case, right? So now the file name expansion comes into play, right? So this star dot text expands to every file name that ends in .txt, right? What are those files? Well, ls will tell you what those files are. ls star.txt, right? So there's two of them. So cat star.txt mashes the contents of big A.txt and little A.txt together, like that. Right? And so the file name, so this expansion, all the expansions that I just talked about, right? So star, question mark, and the square brackets, these all produce a list, what Bash calls a list of strings, right? So star.txt produces the list of strings, right? A.txt followed by a space, followed by little a.txt, right? Right? So the output or the result of a file name expansion is a sequence of space-separated strings, right? So you have to keep that straight. It's a sequence of space-separated strings. As far as your shell is concerned, everything's a string, right? So there are no real data types as far as your shell is concerned, right? Everything's just a sequence of characters, so everything's a string, right? Even numbers, right? So star.txt is just the sequence a.txt followed by a space followed by little a.txt, right? The space is the default word separator in Bash, right? And so that you're going to see that's going to cause some issues, right? In particular, what happens if you have a space in a file name, right? So imagine you create a file. Oh, sorry, not cat touch. File name with spaces. Right? There's your file name with spaces. Right? Notice your shell now is trying to be helpful. Right? The shell is putting single quotes around that file name. Right? So your shell is actually trying to indicate that something funny is happening here. Right? So remember, as far as the shell is concerned, right, everything's a string. If you've got a space in a string, then it's a list of strings. Right? So if you try to do something like ls file name with spaces, right, what you're actually asking for here is, please list information about the file called file name and the one called with and the one called spaces, right? And so it's going to complain, right? It says, hey, there is no file called file name, there is no file called with, and there is no file called spaces, right? And this is a consequence of the fact that pretty much every Unix shell interprets the space as the string separator character, right? So if you use a space in a file name, you have to treat that file name in a special way, right? You have to tell the shell, hey, these spaces actually aren't word separators. They're actually part of the string that I'm interested in. Right? And so we'll see how to do that. Next, I think. Yes, next. All right, so this we're now in the quoting notebook, right? So some of the characters are special to the shell, right? You've seen star, you've seen the space now, you've seen star, right? You've seen question mark, right? You've also seen the dot, which may or may not be special. We'll see in a second, right? Oh, you've seen tilde, right? So the tilde character from last class, right? That guy. That one's also special, right? When you type in tilde, that expands to the name of your home directory. Right? So there are characters that are clearly special to the shell, right? And so the question now becomes well, what if I want to use one of these characters in, say, a file name or something else, or as part of a command or something like that, right? And so the answer is you have to treat these characters specially. And that's what quoting is for in Bash. So quoting is used to remove the meaning of a special character. Right? Okay, so if you've got a special character, so if you have a character that you know is special, and you want to use it as, say, part of a file name, then one way to use that character as part of the file name is to put the backwards or the backslash in front of it. Right? So it's important, this is the backslash, right? It's not the forward slash. Right? Forward slash is the directory separator character. Right? So don't use that one, right? It's the backslash, right? The backslash is the escape character. Okay. A lot of people new to the shell get these mixed up and then nothing works. Right? So if you want to remove the meaning of a special character, you can precede it with a backslash. Right? So what the backslash does is it preserves the literal value of the character that follows it. Right? So in other words, if you wanted to use the space, you could write backslash space, right? And now the shell will interpret that as just the space character and not the word separator. Right? Now you might wonder, so what are all the special characters, right? So I found this on Stack Overflow, right? So if you run that, don't worry about trying to understand it at this point in time. You won't understand this for another few, like 4 weeks, right? So if you run that little program, though, it will tell you which characters does your shell think are special, right? So %sign no plus the hyphen, the dot is not special, right? So it's not considered to be a special character, right? It happens to have a particular meaning when it's the first character of a file name, but otherwise it's not important, right? It's not significant. The forward slash, also apparently not significant, right? Although don't try to use it in a file name because that's the file name, that's the directory separator. The colon, also not special, right? Underscore, at, and equal, not special. But there's a whole bunch of ones that are, right? So all of the following means something to the shell, right? A lot of these shouldn't surprise you at this point, right? The space shouldn't surprise you, right? The exclamation mark is special to the shell. That shouldn't really surprise you either because you saw that just a second ago you can negate a character class using the exclamation mark, right? So it seems kind of, it's not unusual that might be special to the shell, right? This notebook is called quoting, so the quotes are probably special to the shell, right? Round brackets, square brackets, right? And a whole bunch of other characters. These all have some sort of special meaning to the shell. So if you want to use these as part of a file name, you have to treat them specially, right? You either have to escape them, so use the backslash in front of them, or you have to do something else, right? So escaping a space character, that's one way to deal with spaces in file names, right? So if we list the contents of the directory I'm now in, so I'm now in the quoting notebook directory, right? So you'll be in scripts quoting if you're following along. So if I list the contents of that directory, there are 3 files, right? And they all have one or more special characters in them, right? First one has spaces, the second one has a star, right? And the third one has a question mark in it, right? Whenever the whenever ls prints the name of a file that has special characters in it, it always single quotes it, right? What it does if you try to make a file name that has single quotes in it, I'm not sure. But any other special character in it, it will single quote the file name, right? So it's important to remember those single quotes are not part of the file name, right? The file's name is file with spaces in name, right? It's not single quote file with spaces in name, right? Okay, so now what happens if I want to list the contents of those files? Right, so I'm just going to jump into my terminal and do it from here. So I want to go up one directory and I want to go into the quoting directory. Right? I've got a bunch of other files in this directory. Okay, so I want to print the contents of file with spaces in name. right? You should know by now, or realize by now, that's not going to work, right? This is asking the cat program to concatenate the contents of the file named file, the file named with, the file named spaces, and in and name all together, right? Those files don't exist, so cat complains, right? There is no file named file, there is no file named with, and so on and so on and so forth, right? So one way to deal with this is to escape the spaces, like that, right? And now, if you look at the contents of the file, it says, hey, you probably shouldn't use spaces in a file name, which is generally good advice, right? If you want to make your life easy, don't use spaces in your file name, right? It's natural to put spaces in a file name when you're working on an operating system with a graphical user interface, right? So in Windows, Windows doesn't care. Well, Windows doesn't seemingly care if you put spaces in the name, right? Mac doesn't seemingly care if you put spaces in the name. Underneath the hood, they all care, and they're doing something special to deal with the spaces in the name, right? But as far as an ordinary user is concerned, it's not unusual, or it's often desired, that you have spaces in the file name, right? If you're working in Unix or Linux, and you want to keep your life simple, don't put spaces in the file name. Yeah.
What if you have a backslash in the file name?
What happens if you have backslash? You can escape the backslash. So backslash, backslash will escape the backslash. Okay. Yes, you can in fact do that. Right. What's the next one? Oh, so there's another one, right? So there's a file with a star in it, right? So what happens if I do file with a star in name, right? So this one produces some output, but it's not the correct output, right? I want to know what is in that file, right? Or the file with that name, right? Now, you get some output, but it turns out that's not really the correct output, right? So what is actually in file with star and name? With backslash star. It's not letting me escape the, okay. What's going on? File with the underscore in name. There, right? That particular file, all the files only have one line in them, right? So the contents of that file is avoid using the star in file names, right? But when I ran that command, I got that output there, right? So what's happening here is, right, that's a wildcard as far as the shell is concerned, right? So the shell is printing out, this expands to whatever files match this pattern, right? So it expands to file with star in name, and it expands to file with question mark in name, right? The same thing happens if you change the question mark, the star to a question mark, right? The question mark expands to anything that matches this pattern here, right? So question mark means any single character. So it also matches that file and that file name, right? So you're actually printing out the contents of two different files with both of these, right? If you want the contents of just the files themselves, you have to escape the special character, right? Backslash, and away you go, right? Now you've got the contents of the file with named file with question mark in name. Right? And so all of these are all one way to deal with the annoying special characters. Right? There's other ways to deal with this, though. Right? So you can use single quotes around a string. Right? Single quotes basically turns off the meaning of all special characters inside the string. Right? So every character is not special inside single quotes. Right? That includes the escape character, right? So the escape character doesn't work inside single quotes either, right? Now, you can ask the question is, well, what happens if I have a single quote inside of a single quoted string? And the answer is that doesn't work, right? So the way single quoting works is it starts at the first single quote, ends at the second single quote, right? So if you want a single quote as part of your file name, you can't put it inside of single quotes. That doesn't work. You can't escape it either, because single quoting takes away the meaning of backslash, right? So another way to deal with this, and this is the way that ls prints the name of your files by default, if they have a special character in it, is surround everything with single quotes. Right? So this says literally, match literally that file name. Right? And output or cat the contents of the file whose name is literally file with question mark in name. Right? And that one lists the contents of the file whose name is literally file space with spaces, right? And so on and so on and so forth. Right? So single quotes in this particular example also solves the problem. Right? So single quotes will take away the meaning of every special character. Right? Now, perhaps, so it may not make sense right now, but sometimes you want the characters to be special inside of the name. Right? So there are cases where you want to take away the meaning of some of the special characters, but not all of them. Right? And so that's what double quotes are for. Right? There's an error. I'm pretty sure there's a mistake if you're following along in the notebooks. So this thing here, I think in the notebooks that you have, it looks like that. So I'm going to run that again, and you'll see what I mean. Right? So if you see this, that's a bug. It's all right. There's an error in the notebook. Right? Why is there an error in a notebook? Because the backslash is special. I need 2 backslashes in this case. Right? So backslash, take away the meaning of the backslash, and then print and use the literal backslash character. Right? And so now you can see it. Okay, so if you use double quotes around a string, right, it takes away the meaning of all the special characters except for these ones here. Right? So except for those ones there. So inside double quotes, you can use the dollar sign. Right? You might say, well, what am I using the dollar sign for? The answer is, it turns out this is the way you get the value of a variable in Bash. Right? So it's often useful to get the value of a variable and put it into a string. Right? And so the way you do that is to double quote things, right? And then use the dollar sign. You'll see when we do variable expansion later in the course. The backtick still has meaning. So the backtick is this character here. Is that one? It's the little one like that. So it's the little backtick. We're not going to use it in the course. It does show up it shows up a lot if you look up older documentation for the shells. Right? So that used to be a very commonly used character. We're not going to use it in this course. Right? The backslash keeps its meaning. Right? So inside double quotes, right, you can escape other special characters. Right? And depending how your shell is configured, the exclamation mark may have a special meaning inside double quotes as well. Right? Okay, now this backslash, though, is a bit confusing. Notice that there's lots of little rules that you have to either look up or remember. Right? So normally, the backslash will escape all special characters. Inside double quotes, it will not escape all special characters. Right? It will escape dollar sign. It'll escape the other special characters that have meaning inside double quotes. Right? So in other words, the backslash, you can escape dollar, backtick, backslash itself, and the question mark inside and the exclamation mark inside double quotes. All right, so double quoting is probably the most common form of quoting you're going to see later as you go through this course. Right? It turns out it's the one that's most useful when you start to write scripts in Bash. Right? For our purposes right now, they serve the purpose of removing the special meaning of star, question mark, and spaces. Right? So these all work now as well. Double quoting does some other stuff as well. Right? So this stuff here won't make any sense to you. That line there won't make any sense to you at this point in the course. Right? But you need to remember this later on. Right? So double quoting prevents word splitting, it prevents file name expansion, it prevents tilde expansion, and it prevents brace expansion. Right? Tilde expansion we've seen. Right? Remember, tilde expands to the name of my home directory. Right? So this expands to root home / Burton. Right? If you put the tilde inside double quotes, that doesn't happen anymore. Right? Now it gets interpreted as just the tilde character, right? So it loses its special meaning, right? Word splitting, we haven't really seen yet. So animals and error. Okay, so ls, animals, and error, right? So word splitting occurs whenever there's a space inside of a string or a sequence of characters, right? So as far as the shell is concerned, right, you got the command ls, right? And then you've got two separate strings, animals.txt and error.txt, right? That space indicates the space between two different strings, right? Double quotes takes away the meaning of that space, right? So now it thinks you want to list the name, list the information about the file called animals.txt space errors.txt, right? So the space is no longer special, right? It no longer separates two words, right? So that separation of words using a space in Bash is called word splitting. File name expansion we've seen, right? So using the star and the question mark and the square brackets, right? That all results in file name expansion. Double quotes also stops that from happening, right? And you'll see later on in the course, there's other types of expansion as well. Those all still work inside of double quotes, right? And that's why there's a difference between double quotes and single quotes, right? Sometimes you want stuff to happen inside of a quoted string, and sometimes you don't want it to happen. Right? If you never want anything to happen, just use single quotes. If you want to do something like arithmetic, though, inside of a string, which you'll see later on in the course, then you have to quote it. Right? So we'll see more examples of those later on. Any questions before we wrap things up? The dates for the first two assignments, they've been shifted by a few days later into the course. Assignment 1 should come out either tonight or tomorrow morning, right? Depending on when I get it done. Okay?